Alrighty, welcome to the summary of all summaries of this lecture. Hopefully this will be helpful for you to put together everything that you really need to know about the female reproductive system, not including anatomy, but all of the other systems at once, or all of the other phases and cycles at once. So what I'm going to do is I'm going to zoom in here on the left side for now, and then we'll come back to actually writing it all out. So here's this picture that I've been talking about that the book has given you, that I've been cropping and putting in other slides. So I don't know what its actual numbered is or whatever, but it's a huge picture in your book. So the top one is showing you those GnRH levels and then the associated LH and FSH levels during the ovarian cycle, actually during any parts of the cycles. Then paired with it, you have the ovarian cycle just below that, where it's showing you the follicular development and then the corpus luteum development. Then we have the estrogen and inhibin levels and progesterone levels. So what is happening from the granulosa cells, and at what point do the granulosa cells eventually start making inhibin, and then at what point does the corpus luteum actually start making progesterone. Then you have what's happening at the level of the uterus. So what does the endometrium look like? What does the functional layer of the endometrium look like during the uterine cycle? So you start with the menstrual phase, then you start to build up again during the proliferative phase, then you have ovulation, then you have the secretory phase. And then probably the least important for the purposes of this class, definitely very important if you're interested in fertility and so on. But for this class, we don't worry about it too much. But the actual basal body temperature, so some women will keep track, I shouldn't say some women, people with uteruses that are interested in getting pregnant or trying to get pregnant will keep track of their body temperature. And as soon as it starts to spike, usually about by half a degree or a degree or so, that usually indicates that ovulation has happened, is about to happen, and that's one of the best times to actually try to get pregnant. So going through and having vaginal intercourse or insemination, however you choose. So focus on the top four charts. The middle is supposed to show you what's happening during ovulation, or when ovulation is and where everything else lines up with in accordance to ovulation. And then the regular 28-day cycle, so from day 0 all the way to 28, and then you start over again. On the right here, I have something that you do not need to memorize, but I think is relevant because what happens whenever you actually get pregnant? Then what? Where do your hormones come from? So one of the first things that's really important, and let's talk about progesterone first because that's what we know. The progesterone will still be released in some amounts from the corpus luteum. After a certain period of time, though, it doesn't need to be released anymore. Instead, it will rely on the placenta to produce its own pregnancy hormone. And that pregnancy hormone is called HCG, in red here. And that hormone is only shows up, I think, after, like week 7, week 6, I think, something like that. And that hormone is what we call the pregnancy hormone because that is what is actually tested in the urine on pregnancy tests. It stands for human chorionic gonadotropin hormone, something like that. And it'll go in really high amounts during the first trimester, but then after a while it's not useful anymore, and so the placenta focuses on using other hormones like progesterone and estrogen to actually develop the fetus, and HCG kind of dips off later. You will have levels of that in the urine, you should, but not, it's not the most important by the second and the third trimester. Estrogens will eventually be made by the placenta as well during the second and the third trimester. Baby also makes certain levels of these hormones too, so this picture isn't complete. But what I really want you to pay attention from is this picture is HCG. That's that pregnancy hormone that's released from the placenta, and it helps compensate for progesterone. So progesterone will still be released, but not in high amounts. So HCG comes and kicks in and makes sure that the body knows that it's pregnant. So now let's go ahead and draw all of this out. So what I would recommend is taking a piece of paper and putting it landscape, not vertical. Hopefully mine will look a little vertical and a little crammed because I don't have too much room to work with, but if you take one nice standard sheet of paper, this will be a good summary sheet for you. And what we're going to do is we're going to talk about, we're going to go from day, and leave some room on the left. I'm doing this on purpose. We're going to go from day 0, day 14, and day 28 here. And we're going to talk about what happens at each of these. And of course, this is a cyclic thing, so this comes back and restarts every single time, right? And we're going to want to mention at some point what's happening to the female baby, and what happens to the female baby at birth, and what happens to the female baby at puberty, right, before we start actually going through these cycles. Okay, so let's go ahead and take this one at a time, I believe in the order that we talked about them, or at least close to. So first, and I'm going to put kind of a bracket here just to help separate what's going on. So first we're going to talk about the uterine cycle. Okay, so first we start with menstrual phase, right? We start with menses. That's the first one. That's what initiates day 0. Then we transition into the proliferative phase. Oh, and I draw that too big, of course. Well, let me go like this. Okay, and now then we go into the proliferative phase. Okay, so we shed the lining, we're starting to build up the lining, then we finally have ovulation at day 14, and then we move into the secretory phase where we're building it up in case there's an actual implantation. That's it. All right. Next, at day 0, let's go into orange. We're going to have the ovarian cycle. Okay. The ovarian cycle, we're going to start with the follicular phase. And that's the first half of the 28 days. And then that transitions at day 14 to the luteal phase. Right? And if these terms aren't familiar with you and you don't know what's going on necessarily, you could write little notes here, like here we have the corpus luteum. Here you have the primary, secondary, tertiary. Primary has primary oocyte, secondary has primary oocyte, tertiary has secondary oocyte, and so on. Okay. Next, let's talk about oogenesis. So, oogenesis, let's think, oogenesis. So oogenesis, we have ovulation at day 14, right? So I'm just going to make this dots. You don't have to do that if you don't want to, but for me that's going to be helpful for spacing. And right here we have baby, birth, and puberty, so I want to make sure I keep in track with that. So let me go in green. And so let's start at baby. We have baby is born at birth with about 400, or I shouldn't say baby not born at birth, but baby at, not baby, female teenager in puberty has 400,000 oogonia. So you could draw a line here at puberty. Then those transition and become primary oocytes, right? And then we wait until puberty. So these are arrested in prophase 1. And then we wait until puberty to start or finish meiosis 1. So we have those primary oocytes finishing meiosis 1. I'm just going to abbreviate M1 here. And then those primary oocytes go through secondary oocytes, or go through up to metaphase 2. I'm not finishing, so let's put up to metaphase 2. And we have polar bodies here, so and polar body. And now, and of course my spacing. And so now I'm going to go like this. Sorry about that. Like this. And now let's talk about what happens to the oocyte and what happens to the polar body. So let's go ahead and start with, what happens if things get fertilized and what happens if things don't get fertilized. So I'm going to go in a dark green here. for fertilized. Yep, for fertilized. Sorry, I just needed to double check my notes here for a second. So I'm going to put F for fertilized. F for fertilized. So let's talk about what happens to the polar body first. So the first polar body, and I'm going to abbreviate PB actually to save some room. First polar body, it will go ahead and finish and make a second polar body and a third polar body because it's going to finish meiosis 2. And so we have lots of polar bodies. Woohoo, great. The secondary oocyte will finish meiosis 2. And it'll produce a fourth polar body. Oh, and I said I was going to abbreviate, but I didn't. Okay, fourth polar body. Okay, now we wait 9 months. Woohoo. And ta-da, great. And we start all over again. Okay, so what happens if no fertilization occurs? And let me go in another shade of green. So no fertilization. No fertilization. And let's talk about the, again, the polar bodies first. So first polar body. It could go through meiosis 2. It could. So could. Make a second and a third polar bodies. And let's talk about the secondary oocyte. No fertilization, so it just waits. And then it finally leaves with menses at the beginning of the next phase, right? At the beginning of the day 0. All right. So I tried drawing this in a time-sensitive orientation, right? So day 14 we have ovulation, and only then can we actually have fertilization or no fertilization occur, right? And we ovulate a secondary oocyte. All right. Now let's go ahead and talk about what's happening at the axes. So let's go in blue here. Oh, goodness. Sorry about that. Okay. So the hypothalamic, gonadal axis. All right. So again, we have ovulation, our middle, day 14. Okay, let's talk about GnRH. So just like in that graph, right, we're going to have varying pulses of GnRH. So if I were really to zoom in on this, it would look like this, right? And gradually build all the way up until we get enough GnRH that we're making enough LH. And then once we finally do that, then we can dip off and lay low until the next time. And this is GnRH in pulses. Okay. All right, so as GnRH increases, LH is going to increase. So slowly, it's a little less than FSH at first because we don't have as much GnRH. Then we finally build enough, or then we finally have enough pulses of GnRH that we start building enough LH, and then we finally have this big peak, and then we dip down, and no more LH. We don't need to make it any more LH. No, we have that negative feedback going back to the anterior pituitary and the hypothalamus, so we don't make any more LH. And this would be our LH surge, which induces ovulation. Oh, no, let's not do that color. All right, FSH. At first, we have low levels of GnRH, so we're going to have higher levels of FSH to LH respectively. Then we switch that at some point with LH, and then we finally get a huge bump of GnRH, so we get a little bump of FSH, and then just the same negative feedback back to the hypothalamus and anterior pituitary so that we don't have any more FSH production. Okay. Now let's talk about what's happening with LH whenever we have that LH. LH is going to go to the thecal cells. And let's again draw in ovulation. So at first we're going to be making precursor estrogen. So estrogen, that's not estrogen yet. To give to granulosa. All right. Then we have the LH search, and this, let me draw the arrow all the way to the, so release of oocyte, and that's it. Then LH just kind of down. That wasn't meant to be bumpy. It was meant to be down. Okay. Next, let's talk about FSH. So FSH to granulosa cells. So at first it's low, right? So we have nothing really going on here. I'm sorry. First it's high because we need to immediately start making estrogen to prepare the endothelial lining. So we have some estrogen being made by the granulosa cells, but then we kind of dip off because we don't need that help anymore because the thecal cells started giving us that those pre-estrogen molecules, and so now the granulosa cells can finish making their own estrogen, and then we have a little bit of a bump here, which we don't need to talk about, but that also helps with ovulation. And then the rest of the time after ovulation is where they start to make inhibin. So just like spermatogenesis, we need to make inhibin to also help shut off everything and say, hey, we're done, we've made enough. So inhibin here is going to be released from the granulosa cells, negative feedback to both anterior pituitary and hypothalamus. And so that's the rest of this until we start all over again. Okay. And now if we want to draw out what's happening with estrogen and inhibin, and ovulation. Okay, so inhibin is slow, we don't have a lot, then at ovulation we start making it, and then we continue to make inhibin enough to tell the anterior pituitary and hypothalamus that we're done, and then we finally dip off and we're done. Inhibin. Okay, estrogen. Okay, the granulosa cells start making it a little bit, then they get a lot of help because the thecal cells finally kicked in and gave some help to the granulosa cells. And so then we make a bunch of estrogens, and then this kind of dip off a little bit because we're focused on progesterone. We're not pregnant yet. If we were pregnant, we would make a little bit more. And then right before shedding, there's actually a little bit of a increase of estrogen to help promote menses. Okay, and now while we're talking about hormones, let's go ahead and finish off with what's happening at the corpus luteum. Ovulation. Okay, so corpus luteum doesn't exist. So I'm not even gonna draw anything here in the pre-ovulation phase. It doesn't even exist. But as soon as it does exist, then it starts secreting progesterones, and until finally menses, and then it dips off. So progesterone. Sometimes in the literature, you'll see this abbreviated as P4. And then whenever it dips off and we don't eat it anymore, then it becomes a corpus. Oh, goodness. Corpus albicans. All right. Last but not least, let's go ahead and shift over this. So if you have room on the right side of the page, I would go ahead and do that. So the ovulation can be down here. I'm going to go ahead and just cut this and move it to the left because I don't have room. But in order to keep your progression, we're going to talk about pregnancy. So if you want to keep it in line with what's happening with your oogenesis from up here, I would do that. So I'm going to go ahead and erase this. So I'm going to kind of cheat here and bring my ovulation line down here because we can't get pregnant before ovulation anyway. And let's go blue. and time, right? Ovulation, pregnancy, woohoo, great. So are we pregnant? Right, so what is the placenta releasing? So the placenta, as soon as pregnancy, or not as soon as pregnancy occurs, but after some time, fertilization occurs, then you have a spike of HCG, and it's usually lowercase h, capital C, capital G, and you're going to have high levels of that, and then after delivery, low levels. So I know in the graph it shows you it dips down. We don't care that you know the details of what HCG looks like, just that it's prevalent whenever you're pregnant. So delivery, and it goes bye-bye. All right, so that's all that I have for you for this summary thing. I hope that this is helpful. I think being able to think about it one at a time is really important, and then being able to see where it is in relation to everything else. So being able to reproduce this, I think, will be really useful for you when it comes time for studying. But hopefully this will be a good resource for you.